Greetings to all. The session is related with the intermediate chemistry on the international floor for entrance and competitive exams as well. And India is conducting JEE Advanced and JEE Mains twice a year for the admission into IIT and NIT stream. A NEET exam will be conducted by National Testing Agency across the India for medical entrance examination. Telangana and Andhra Pradesh government are conducting MCET exam for the admission into BTech stream, that is the technical domain. And government portals, government organizations are conducting job opportunities for various aspirants where general studies common question paper will be provided. There we can find the content what we are discussing today. Let's enter into our today's session. The Nobel Prize in the field of chemistry for the year 2012 was awarded jointly Robert L. Lefkowitz and the Brian K. Kobylka for the studies of G protein coupled receptors. So the kind of session, the kind of research carried on biomolecules and a protein binding with the receptoric site, that kind of tendency, binding tendency was focusedly studied over and they were accorded with the Nobel Prize in the field of chemistry for the year 2012. And these two are the scientists responsible for outstanding contribution to accord the Nobel Prize in the field of chemistry for the year 2012. Robert J. Lefkowitz, Brian K. Kobylka. These together worked upon that protein efficiency binding on receptoric site, G protein efficiency binding on receptoric site. Because of their contribution, they got awarded, laureated with the Nobel Prize. That is the world recognition. Right. The Royal Swedish Academy of Sciences has decided the award Nobel Prize in the field of chemistry for the year 2012 towards Robert Z. Lefkowitz. He belongs to Harvard Hawks Medical Institute and Duke University Medical Center of United States of America. Brian K. Kobylka belongs to Stanford University School of Medicine, Stanford, United States of America, for the studies of G protein coupled with the receptoric site. This is the way they got contributed for the biomolecules, and that is recognized as the prestigious Nobel Prize. The smart receptors and cell surface. Your body is fine-tuned system of interaction between the billions of cells. Everybody aware how the bricks are the building blocks of the entire building. In the same manner, cells are used to construct, billion cells are used to construct the entire living organism. Each cell has the tiny receptors that enable to the sense its environment so it can adopt the new situations. Receptor having the tendency to react towards the environmental conditions. In what way environment is treating on that, so that it will show its a reaction, and according to the situation, it able to adopt the kind of things whatever required. Robert Lefkowitz and Brian Kobylka are awarded the prize, Nobel Prize in the field of chemistry for the year 2012. It is the groundbreaking discovery in the field of G protein coupled with the receptoric site, right? For a long time, it has remained a mystery how cells could sense their environment, how the cells will react towards the environmental condition. Either you're in condition with the water, either you're in condition with the cool weather, or else any hot condition is provided, any chemical environment is there, what kind of reaction they will show. What is that kind of correlation between the cells and reaction towards the environmental condition, that vacancy we already noticed. The scientists knew that hormones such as adrenaline has a powerful effect, increase the blood pressure and making the heart beat faster whenever the person feeling stress, or else any kind of thing he is more focused about, so that adrenaline secretes the hormone, and that will rise the blood pressure and even heartbeat will become faster, right? They suspected that cell surface contains some kind of recipient of for the hormones. Any kind of abnormal condition if they are facing, then only such kind of deviation we can notice in the normal blood pressure and beating of heart. But what these receptors actually consisted and how they worked remain obscure for most of the 20th century. Why they're responding, what kind of changes we are noticing, how it is possible, all this is not known till the 20th century. Lockwitz started to use radioactivity in the year 1968 in order to trace the cell receptors. So here radioactivity is the tool in order to identify how the receptors are responding towards the environmental conditions. So that the effective analogy got contributed in the year 1968. He attached an iodine isotope to various hormones. Thanks to the radiation, he managed to unveil several receptors. Among those receptors, adrenaline, beta adrenergic receptor, his adrenaline and adrenergic receptor are taken into the consideration, and labeling is possible. That is, the isotopic labeling was done by means of iodine that is bounded to the hormones, and there is a contact with the environmental conditions, and they gone through how it is responding, what kind of changes are there. That radioactivity is used to visualize or used to monitor what changes they are facing, right? So the researchers extracted the receptor from its hiding place in the cell wall and gained an initial understanding how it works. Okay, so in that tiny cell wall will be there for the protection, and on that cell wall, inside the cell wall, they identified the receptor where exactly it is located, and they worked upon them, right? The team achieved its next big step during the year 1980s. The newly recruited Kobelko accepted the challenge to isolate gene that code for beta adrenergic receptor from the gigantic human genome. So, beta adrenergic receptor was successfully collected from the hormone genome of the human being, and genetic code was analyzed upon that, and the isolation of the entire study was done, right? His creative approach allowed him to attain his goal. When the researchers analyzed the gene, they discovered that receptor was the similar to one in the eye that captured the light. Okay, so our eye is more convenient to capture the light. We can observe whatever colors we are seeing, whatever changes observed in front of you. Everything is visible because of light only. How light will affect the how light will be captured by your eyeball. In the similar manner, receptor will show the reactivity towards the environmental conditions. There is a similarity. Today, this family is referred to as a G protein coupled receptors. About 1,000 gene code for such a receptor, for example, light, flavor, odor, adrenaline, histamine, dopamine, and serotonin. These many hormones taken into the consideration, and how these kind of receptors are reacting whenever these hormones are in direct contact. Like whenever light is in contact with that receptoric site, how it is showing the effect. And flavors, various tasting flavors will be there, various odors will be there, adrenaline gland, adrenaline secretion will be there. Histamine is the kind of what pancreas is able to secrete this histamine. So beta histamine that used to create the allergy tendency, and this is the kind of secretion and hormone which also impact that kind of receptoric site. Dopamine will be there. Dopamine is the kind of chemical secretion from the neurological system. It used to regulate the neurological system. Dopamine is very efficient hormone which used to give the impulses and strength to the nervous system. Dopamine deficiency causes neurological disorders called Parkinson disease, right? Serotonin, it is also the kind of secretional hormone which also show the impact on the receptor. How it is impacting can be understood. About half of the medications achieve their effect through the G protein coupled receptors, right? So many kind of changes, and what kind of impulses, what kind of changes, kind of interaction will be there. And that entire analysis, in-depth analysis, was carried by these two scientists together, Robert Lefkowitz and Brain Kobelka, so that they are awarded with the prestigious Nobel Prize in the field of chemistry for the year 2012. This is the way the extensive study regarding the Nobel Prize in the field of chemistry was done in the year 2012. Move on to question number 2, Cambridge Assessment International Litigation. The formula for the sulfuric acid is H2SO4. This is called a chemical formula. To calculate the relative molecular mass of the sulfuric acid, hydrogen with the, how many atoms you can notice hydrogens are 2. Relative atomic mass for hydrogen. So individual atomic masses we are calculating. Hydrogen is one and only one element with the one proton without neutron, so that its atomic mass is 1 itself. So let me go for atomic weight of entire hydrogens. 2 hydrogens multiplied with 1 atomic mass, so that 2 contributing hydrogen. And we have to go for remaining sulfur and oxygen as well in order to calculate molecular mass. So let's put the table sulfur number of atoms. How many atoms are there? Sulfur only 1 atom is there. So put 1 over here, and relative atomic mass for the sulfur. Sulfur atomic number is 16. 16 protons, 16 neutrons go for 32. 32 is the atomic mass. So 1 sulfur and 32 atomic mass, so that for sulfur contribution 32 is the mass. Oxygen. If you count oxygens, H2SO4 oxygens are 4. So that 4 oxygens and each oxygen contributing 16 atomic mass. So that multiply 4 with the 16, so that 64 contributing the atomic mass of entire 4 oxygen atom. Then let me take the sum of all three. 64 plus 32, it will become 96. 96 plus 2, 98 it will be. This is the relative molar mass. This is the way we can. First of all, we have to go for calculating the individual atomic masses and their coefficient taken into the consideration, so that after considering atomic masses, go for the addition of all. That is called summation of atomic masses, so that molecular mass will be achieved. This is the way question number 2 can be solved, right? Sulfuric acid, not only sulfuric acid. If you take any of the chemical formula, if you know the atomic mass is equal to proton number plus neutron number. So that whatever atomic number is there, approximately it will be a double of atomic number, right? Approximately, not always true. Approximately double of the atomic number is given for the atomic mass. This is the way molar mass can be calculated. So for question number 2, we got the perfect answer over here. Sulfuric acid molecular weight is calculated as 98. Move on to question number 3, 2016 paper 1 question. It is the measured product in the following reaction sequence. And one thing I would like to extend over here, we are conducting series of sessions over intermediate, particularly entrance and competitive exams. So many are available on the channel World of Competitive Chemistry. You can access all the series of sessions whatever we are conducted earlier. And if you are subscribing, so that we will achieve more such kind of new content and authentic information, for sure are getting your goal. So that is possible whenever you are subscribing this channel, right? So move on to question number 3. We have a benzene ring with a double bond O, and here we have isopropyl. We can say isopropyl phenyl ketone. This is a common name. So IUPAC, in order to mention the IUPAC name of this compound, methyl phenyl propanone, IUPAC nomenclature is designated as International Union for Pure and Applied Chemistry. So that alkanone is the name, and this is the way you can go for the IUPAC name. Formaldehyde, if treated under excessive quantity, alkaline conditions are mentioned and heat is provided. And in this second step of reaction, formaldehyde, acidic condition, catalytic amount will be added, so that you can achieve a product of bicyclic ring system. And this is said to be a kind of cyclic ether. You can notice. And in order to achieve that one, first of all, polarize the bond in the presence of formaldehyde and alkaline conditions and warm. a temperature is provided over so that the bond polarized according negative charge and the oxygen and positive charge at carbon. So that negatively charged oxygen will bond to the carbon. This is the nucleophilic addition at this carbonylic carbon atom so that it will be added as a CH2O minus. After the addition of CH2O minus, one more molecule of formaldehyde will be added over so that one more kind of this cyclic ether linkage will be generated. And here the positive charge existing can be neutralized by the acidic medium protonation carried so that we will achieve a neutral compound like this. This is the way the compound 1 will be accorded by these series of reactions on this phenyl propyl ketone. For question number 3, option number A is the right answer. Let's go with the question number 4. According to the molecular orbital theory, what is the correct answer we have to depict? Okay, C2 minus 2 is expected to be diamagnetic. O2 plus 2 is expected to have longer bond length than the oxygen molecule. N2 positive, N2 negative have the same bond order. Helium plus has the same energy as two isolated helium atoms. Okay. So this is the kind of session we are going to discuss in detail, where C2 minus 2 is expected to be diamagnetic. They are saying, right? So C2 minus 2 means so each carbon is added with one electron so that it is exactly resembling the nitrogen molecular orbital geometry. If you observe 2s orbital is having 4 electrons in filled in bonding to anti-bonding to. 2p orbitals are contributing 336 electrons for molecular orbital formation. Pi 2px 2 electrons, pi 2py 2 electrons, sigma 2pz 2 electrons will be occupied so that the entire molecule is said to be a paired electron containing molecular geometry. Obviously, it is the of diamagnetic in nature. Any molecule with the completely paired electrons is the kind of diamagnetic molecule that is given in the option A. Move on to O2 positive plus 2 is expected to have the longer bond length than O2. O2 dipositive is nothing but each oxygen is contributing plus charge. So that, sorry, oxygen is of 8 electron system. 8 electrons plus 8 electrons, 16 electrons will be there. 16 electrons, but here dipositive indicates we have to remove 2 electrons. Whenever 16 minus 2, so that 14 electron system it will be. Whenever 14 electron system it is acquiring, it is resembling again nitrogen. Whenever it is resembling nitrogen, so that you can find a triple bond among the two oxygen atoms with the dipositive charge. Oxygen bound together by triple bond. But oxygen molecule, if you go for the O2 molecular geometry, where filling of electrons is the kind of this manner, 1s electrons, 2 plus 2, 4 1s electrons will be arranged in this manner, bonding to anti-bonding to. 2s electrons again 4, so that bonding to anti-bonding to. 2p electrons are 4 plus 4, so that 8 electrons will be there. You can fill sigma 2pz 2 electrons, pi 2pz 2, pi 2py 2, pi star 2px1, pi star 2py1. So that the entire molecular geometry is kind of paramagnetic in nature with the 2 odd electrons for oxygen molecule, right? But if you calculate bond order, half into bonding electrons minus anti-bonding electrons is the formula, where 2 plus 2, 4 plus 2, 6 plus 2, 8 plus 2, 10, 10 minus 4, sorry, 2 plus 2, 4, 5, 6. Okay. 10 minus 6, 4, 4 by 2. So that 2 is the bond order. That means 2 oxygen atoms are bonded with the double bond. But in case of this one, 2 half into bonding electrons minus anti-bonding electrons. 2 to 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10. 10 minus anti-bonding electrons are 4. 10 minus 4, it will be 6. 6 by 2, it will be 3. So that O2 plus 2 bonded with the triple bond. Here you can clearly notice 10 minus 4 by 2. So triple bond you can notice here in case of this molecule. In case of this oxygen molecule, 10 minus 6 by 2, it will be 2. So here triple bond and double bond, where the bond length is longer. As the bond order is more, bond length will be decreases. Bond order, bond length, both are reciprocal to each other. Both are inverse to each other. Both are opposite to each other. Greater the bond order, lesser the bond length. So that O2 dipositive is the shorter bond length, but O2 neutral is the longer bond length you can notice. This is the way O2 dipositive have the longer bond length is the wrong one. Being it is the triple bonded ion, so that bond length will be shorter. Whereas O2 is a double bonded, so that bond length will be longer. Whatever they said is incorrect. Move on to N2 positive, N2 minus. N2 positive means what happens? N2 positive. This is a simple N2. That means a neutral nitrogen molecule. N2 positive means let me remove one of the electron from the source. Whenever one of the electron is removed, so that one of the electron in this sigma 2pz will be removed. So that the question is N2 positive, N2 negative have the same bond order. Let's go with the bond order for N2 positive. N2 positive, 1 electron less. So that let me count bonded electrons 2 plus 2, 4. 4 plus 2, 6. 6 plus 1 only, 7. 7 bonded electrons minus 2. 7 minus 2, it will be 5. So 5 by 2, what will be the bond order? 2.5. For N2 positive, 2.5 will be the bond order. Bond order is equal to half into number of bonded electrons minus anti-bonding electrons. That will be 2.5. N2 minus we will look after. N2 minus if you are going with, one more electron will be there. Minus means one more electron. Here you can notice one more electron in this anti-bonding orbital. Let me calculate bond order. 2 plus 2, 4 plus 2, 6 plus 2, 8. 8 minus 2 and 1. 8 minus 3. 8 minus 3, 5 again. 5 by 2, 2, 2 is 2.5 again. So that whatever N2 positive and N2 negative they are saying, both are having equal bond order. Both are having equal bond order. So that let me put right mark over here. So let me put a right mark. Okay, that's the reason why for question number 4, you can find multiple answers. Obviously, C2 minus 2 is having diamagnetic nature. N2 positive bond order becoming 2.5, N2 negative bond order becoming 2.5. That means same bond order is the correct option. Helium-2 positive has the same energy as the 2 isolated helium atoms. That absolutely wrong, because helium-2 positive has the same energy. Isolated helium atoms are having lesser energy because they are noble gases. Always monoatomic noble gases are extremely stable, and their stability is due to lesser in the extent of energy. So that helium-2 positive is having higher energy in compared to two isolated helium atoms. That is because here helium is having 1s2 completely filled electronic configuration, but helium-2 positive is having 1s2 1s2 bonding, sigma 2 bonding, sigma star anti-bonding 2, and uh, 4 electrons, 2 electrons plus 2 electrons. 2 electrons plus 1 electron only, because they are mentioning helium positive, right? So one helium able to contribute 2 electrons. In either helium plus contribute 1 electron. 2 plus 1, 3 electrons to be filled. In order to fill the 3 electrons, what happens? Sigma bonding will be filled with 2 electrons, and sigma anti-bonding will be filled with 1 electron. Total 3 electrons are there. In order to get the completely filled, one more electron is required, that is not there. And moreover, half filled, incompletely filled over there in comparison to the completely filled helium 1s2. So that Both are not having same energy. Rather, helium monoatomic is having lesser energy, higher stability in comparison to helium 2 positive, so that it can be cancelled out. For question number 4, the expected answers are A and C. AC is the answer. Let's go with the question number 5. It is collected from 2022 Telangana MSET examination. Unknown inorganic compound A is used for the water softening. Water softening, why we require water softening? If water contains hardness, that is not beneficial to the healthy survival, because most of the diseases are caused by water impurity only. Waterborne diseases are more common if contaminated water consumed. That's why proper softening of water is very essential. Hence, the compound we are using is A to be used for water softening. A reacted with sodium carbonate so that the alkaline solution will be generated, which is said to be a B. Whose pH is 14? 14 pH compound to be identified. On reaction with carbon dioxide gives cloudy precipitate. Cloudy precipitate, that will be obviously calcium hydroxide, because cloudy precipitate of calcium carbonate will be generated by blowing carbon dioxide gas. The compound must be calcium hydroxide. A is understood now. There is a clue over here. This is called lime. And water softening method will be lime soda process. Okay, we will discuss in detail later. And whatever be generated that is an alkaline compound can be treated with calcium oxide as well, so that unknown organic compound C used to give benzene. Whatever organic compound we are taking as C, that should be converted into benzene. What are A, B, C respectively? Here calcium hydroxide, calcium hydroxide, calcium. Let's screen out all the options whatever provided. Calcium hydroxide A, lime. This calcium hydroxide is correct. Calcium hydroxide is correct. Calcium hydroxide is correct. Calcium is wrong, because upon treating with carbon dioxide, calcium metal will not be forming cloudy precipitate, so that you can cancel out option 4. There is a provision for 1, 2 and 3. Okay. So here first A will be used for water softening. That method is called lime soda process. Now, calcium hydroxide can be treated with sodium carbonate. Sodium carbonate, whenever treated with that one, the compound which is generated called sodium carbonate, when combined sodium carbonate is generated, you can cancel out, because adding reagent is sodium carbonate, even product is also sodium carbonate. Where is the meaning? It is the meaningless. There is no sense of meaning, so that you can cancel out option 1 as well. Option 4 is removed. Option 1 is removed. Only the possibility for 2 and 3. Let's trace out among these two. Okay, so here second option, it might be sodium hydroxide, because in both the cases we have sodium hydroxide only. So that whenever calcium hydroxide treated with sodium carbonate, the probable product will be sodium hydroxide only, that is possibly having pH number of 14. That is perfect. So that either 2 and 3 are correct. So that 2 and 3 there is a ambiguity. Let's go with the another step. A is calcium hydroxide. Reaction with carbon dioxide, that is giving cloudy precipitate of calcium carbonate, so that you concluded calcium hydroxide is there. This is clear. And B. What is B? Sodium hydroxide is called B. That sodium hydroxide and calcium oxide together treated with unknown compound giving benzene. Okay. So there is a ambiguity between, this is called what? Phenyl ethanoic acid. This is called benzoic acid. If phenyl ethanoic acid is treated with sodium hydroxide and calcium oxide, the product will be toluene. Toluene means methyl benzene. Whenever the sodium hydroxide and calcium oxide reacted with benzoic acid, the product is benzene. They are saying the product is benzene, so that you have to go with this benzoic acid rather than phenyl acetic acid. phenyl acetic acid or phenyl ethanoic acid, so that you can get option 2. Only the provision for option 3 we have. Okay, this is the way we can go for odd man out. And finally, we got the exact answer, whatever required for the given problem. And the entire series is provided with the keys for with the perfect key for your perfect understanding. Okay. Calcium hydroxide is called lime water. That lime water can be treated with carbon dioxide, so that there is a formation of calcium hydroxide. Calcium hydroxide will be formed. Okay. So whatever calcium magnesium hardness is present, the lime is the exact chemical used for the removal by complexing. Okay, lime is the calcium hydroxide, lime soda is the method. Here, soda lime water is the water softening method. That is the traditional method, first introduced method of water softening, where lime is said to be calcium hydroxide, soda said to be sodium carbonate. Okay, so whenever these two are treated together, so that what happens, calcium magnesium retaining hardness can be removed. Lime is chemically composed by calcium hydroxide. Soda ash is made up of sodium carbonate, so that hardness of water can be removed. This is the way a water softening method is carried. A is said to be a calcium hydroxide. It's very clear now. Let's move on to another point. Whenever sodium carbonate is reacted with calcium hydroxide, there is a formation of sodium hydroxide and calcium carbonate. The product formed is sodium hydroxide, that is said to be B. A calcium hydroxide reaction with sodium carbonate, sodium hydroxide will be generated, that is mentioned in this equation, sodium hydroxide. And next step, carbon dioxide reacts with lime water, giving rise to calcium hydroxide. Calcium carbonate will be formed. The final product is said to be milky white precipitate called calcium carbonate. You can clearly notice in this test tube, right? This is the way what they are saying. Calcium hydroxide reaction with carbon dioxide giving cloudy precipitate. We already gone through. Now let's move on to B with calcium oxide. B means sodium hydroxide. Sodium hydroxide reaction in combination with the calcium oxide. Upon reaction with benzoic acid, this is the kind of decarboxylation. Removal of carbon dioxide is the process called decarboxylation, and a pure benzene will be obtained whose molecular formula is C6H6. That is perfectly justifiable by the option 3. Benzoic acid is the compound, gives the benzene upon decarboxylation with the sodium hydroxide and calcium oxide together. For question number 5, option 3 is the correct answer. Let's move with the question number 6. Question number 6 is given with the assertion and reasoning type of question. Boron hexaquo trication is mentioned over triaquo boron plus 3 and boron OH taken 4. Tetrahydroxy boron negatively charged 1 will be taken. Here one positive complex in either negative complex form octahedral and tetrahedral structures. This is assertion and reasoning. Being electron deficient, boron readily react with Lewis bases like water and OH minus, right? So this is the way the question will be given. Then how can we answer for this question? Let's see. Blindly, you can cancel out this assertion part because boron hexaquo complex not yet all possible in the practical sense, because boron is the atom with the atomic number of 5 and electronic configuration is 1s2, 2s2, 2p. One electron will be there, p orbital, p block will be started boron itself, and it is of group 13th element and first element, so that 2s2 2p1, there is no d orbital, there is no d electrons in that. How can it form d orbital containing complexes? In order to go for octahedral complex, the compulsory provision for d orbital presence. Second principal quantum number may not accorded with any d orbital, so that there is no question of octahedral complex with the boron atom. Cancel out. Being electron deficient, boron readily react with Lewis bases like water and OH minus, perfectly correct. There is the deficiency of electrons over boron. Boron is having 1s2, 2s2, 2p one electron system, so that electron deficiency will be there on the boron, so that it can bind with the water and OH minus. That perfectly correct. A is false, but R is true. Let's go with the detailed explanation. What they are saying, boron hexaquo plus 3 is not feasible. That is because of lack of d orbitals. This we concluded. And boron hexahydroxy complex, if you see, that is tetrahedral only. That means whatever they are mentioning, half is correct. This part is correct, this part is wrong. Boron couldn't form the octahedral complex due to the absence of d orbitals, but boron tetrahydroxy complex is existing. This is possible. With the 147.5 picometers of bond length between boron and oxygen, this kind of complex is existing and it's feasible, right? Here it is clearly mentioned. Boron hexaquo trication couldn't exist due to the absence of d orbitals, and this tetrahedral complex is possible to exist. Being it is tetrahedral, sp3 hybridization is possible. And boron family can show boron is able to form reaction with able to react with water and gives rise to the boron oxide. Boron oxide will be generated. And moreover, boron can be treated with alkaline solution and generate sodium borate. This is the way both the reactions are possible. Boron able to join with the water and hydroxide in a convenient manner, and the products we witnessed just now. So that that possibility is purely because of electron deficiency. 2s2 2p1. So that vacant orbitals are located on the boron, having natural tendency to accept the electrons from the Lewis bases. What is the meaning of Lewis base? Any substance having natural tendency to release one electron pair is called a Lewis base. Water and hydroxide are Lewis bases. So that Lewis bases are able to contribute the electrons and satisfy the deficiency of boron atom. Reasoning is correct. This assertion is wrong. That is given the option number 4. For question number 6, option 4 is the correct answer. By this, we successfully completed the entire session, and we gone through different dimensions of chemistry, where organic chemistry part mechanisms got discussed over, and problematic sessions are clearly manifested, and gone with the inorganic part, physical chemistry. Everywhere we have the impression of knowledge, right? So that the content whatever provided is high quality, and most of the times repeated in the so many competitive and entrance exams as well. From the authentic sources of websites, we collected the entire information. I assure for your the success in your examinations, whatever you're attempting in your near future, go through the sessions in a regular manner, so that you can get the idea how the question analogy will be there, what will be the criticalness of the question, and how to answer if the question is given, what are the possible ways. Everything is given in the perfect order. So that I am requesting you to like the channel, comment. In order to comment, we have a question here. In order to put the answer in the question box, the question for the session is, in the boron family, the element which is said to be metalloid. Let me repeat the question. The element in the boron family is regarded as a metalloid. You have to answer this question in the comment box for this session, and share with the aspirants who are more curious about the examinations and especially about the chemistry, so that definitely they can improve their towards learning chemistry in the maximum extent, and subscribe the channel so that you will get regular updates in the near future. Thank you for your patient listening. Thank you, one and all.